Hello guys, today I'm just doing a past paper walkthrough for the exam board Cambridge iGCSE. This is for the subject computer science and this is a paper 1 theory exam with the code 0478/12. This is for the May-June 2022 series. This is just a recent paper that has been done by the examinations like a few months back. This paper is going to be 1 hour 45 minutes. So this is just going to be a quick walkthrough in this paper on how to solve all the questions. And if you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And yeah, let's begin with the video. Alright, so the main instructions that you guys must take from this is to always use a black pen or dark blue pen. Now the reason is because this paper is most likely to be scanned, so it's better for you guys to use black font while writing this paper down. Alright, so just bring a black pen to the exam. Total mark for this paper is going to be 75 marks. Alright. Okay, so we're going to go with the first question. Now the first question states that the denary values are to be converted to binary values to be processed by a computer. Now you're going to draw one line from each denary value to the correct converted 8-bit binary value. Now there are many ways in solving or converting values from denary to 8-bit binary. I'm just going to follow the method I frequently use, so you guys can use any method you guys like in order to solve these type of questions. So the method I use is I just create a table of all the 8-bit binary values, and now we have the numbers 41, 174, and 86. So since we know that, we're going to look for a value that is going to be less than 41. So we know that 128 is greater than 41, so we're going to put a 0 there. We know that 64 is greater than 41, so we're going to put a 0 there. 32 is less than 41, so what we're going to do is we're going to do 41 minus 32 to give you a value of about 9. Now we're just going to put a 1 there since 32 is less than 41. Now we're going to repeat the same process again. We have the value 9. 16 is greater than 9, so it's going to be a 0. 8 is less than 9. So what we're going to do is, again, we're going to write 9 minus 8 is going to be equivalent to 1. And we just place 1 there at 8 because we can use 8 in this process. Now we have the value of 1. We know that 4 and 2 are greater than 1, so we're going to place zeros there, and we can use 1 minus 1 is going to give us 0, and we're going to get a value of about 1. Alright? So we just cut out all this working so that you guys can see it much more clearly. So this is for 3 marks. Do show your working in the working space given to you guys so that you guys can efficiently solve this type of question. Now we're going to solve for the next denary number. Now this is going to be 174. We know that 174 is greater than 128, so you have 174 minus 128. This is going to give you a value of about 46. So we're going to place 1 there. We know that 64 is greater than 46, so we're going to put a 0 there, and we know that 32 is less than 46. So what we're going to do is we're going to have 46 minus 32 to give you a value of about, let's say, a value of about 14. So we're going to place 1 there since we use 32. Now 14 is less than 16, but 14 is greater than 8. So we're going to place 0 here. And 14, since it's greater than 8, we're going to use 8, and we're going to place 1 there. So it's going to be 14 minus 8. It's going to give you a value of about 6. So we're going to use 8. Now 6 is greater than 4, so we're going to use 4 as well. So you have 6 minus 4 is going to give you a value of about 2. Now since we know that 2 is equivalent to 2, we're going to use 2 in this equation. So you have 1 here. We're just going to place 1 there. It's going to be 0. Now we're going to repeat the same process now for 86. It's just the same method, guys. Just place 1 for all the values you're using in the subtraction, and place 0 for all the values that are either greater than the value that is given in the subtraction process. Now 86 is less than 128. That's going to be a 0. And we know that 64 is less than 86. You're going to have 86 minus 64 to give you a value of about 22. Now that's going to be placed 1 there. We know that 32 is greater than 22, so we're not going to use that. We have 22 minus 16. 22 minus 16 is going to give us a value of about 6. So we're going to use the 16 here and place 1 there. 6 is less than 8, so we're not going to use 8. 6 is greater than 4, so we're going to just repeat the same process, 1, 1, and 0. Now these are all the values that we've got for, these are all the binary, 8-bit binary values that we got for the denary numbers 41, 174, and 86. Now we're just going to match all these values together. So you have 41, this is going to be 0, 0, 1, 0, 1, 0, 0, 1. So this is going to be, your answer is going to be somewhere around here. This is going to be answer. 174, we got 1, 0, 1, 0, 1, 1, 1, 0. That's going to be close match to this value here. 86 is 0, 1, 0, 1, 0, 1, 1, 0. So we're going to highlight it here. So based on the calculations, I've just matched the values together so that we can score these kind of good marks. All right. Okay, just confirming if these answers are correct. Just checking our cross-checking of values. We're correct, and yeah, we're correct. All right, let's move on to the next question. Now, the next question is that binary values can also be converted into denary values. Now, give the correct denary value for the 12-bit binary value 000, 1010, 1010, 111. You have to show all your working. Now, here again, I've drawn a table because this is a method that I follow. You guys can follow any method you guys like in order to convert from binary to a denary value. Now, what I'm going to do is I'm going to start from the right to the left. So we're going to move from the right to the left in order to place these values all starting from 1, 2, 4, 8, and as we move on from right to left. So we're going to have 1, 1, 1, 0, 1, 0, 1, 0, 1, 0, 0, 0. Now, once I fill the table from right to left, what I'm going to do is I'm going to add all the, let's say, all the 8-bit binary values with 1 in them. So we know that 256 is being used. 256 plus 64, since there's 1 corresponding there. 64 plus 16 plus 4 plus 2 plus 1. That's going to be your value in that case. So it's going to be 256 plus 64 plus 16 plus 4 plus 2 plus 1. That's going to give you a value of about a denary value of about 343. So that's going to be your denary value, 343. So this is a method that I use in order just to convert the values. I'm just going to write this down much more better. So we have 343. That's going to be your denary value. Let's move on to the next question. Now the next question is another conversion again. Now this time it's going to be from an hexadecimal conversion to an 8-bit register. You guys can use any method you guys like. So the question is about hexadecimal is used for hypertext markup language, HTML color codes, and HTML color code is, you can see that there's a hashtag 2F1, 5D6. Each pair of digits is stored as binary in an 8-bit binary register. You have to give the 8-bit binary value that would be stored for each pair of hexadecimal digits. So now the trick here is, well, let's say the tip here is to split these hexadecimal values into 2 bits. Like that is technically, let's call it a nibble. So a nibble is made up of 4 bits. So what we're going to do is we're going to take this 2F. I'm going to take 2F and I'm going to split it into 2 individual units. So that is let's say in 4 bits in this case. So we have 8421, 8421. Now this is a table that I've drawn, I've written down, is that this is a denary and hexadecimal table. So all the numbers, let's say all the denary numbers from 0 to 9 have the hexadecimal values from 0 to 9, but all the denary values from 10 to 15 have hexadecimal digits all the way from A to F. Alright, so we're going to draw, let's say we're going to write down all these values. Since 2 is going to be 0010 based on the conversion, and we know that F is equivalent to 15, so that's going to be 1, 1. 8 plus 4 is going to be 12, so we're going to have 1, 1, 1. So now all we need to do is just write this down in your table here. So you have 0, 0, 1, 0, 1, 1, 1, 1. Now this is going to be your answer for 2F in 8-bit binary register. All right, let's repeat the same process for 15. Now 15 is not taken as F completely. We're going to split these values into 2 values. You have 1 and 5. So this is going to be 0, 0, 0, 1, and 5 is going to be 0, 1, 0, 1. So we're going to individually take these units as they are. So you have 0, 0. All I've done is I've just converted them. So you have 0, 1, 0, 1. So you have these kind of values. Now D6 on the other hand, you have to do the same repetition again. We're going to just split these values. What I'm going to do, So I'm just going to raise this so that we can see how to convert the value for D6. D6, you're going to split these values into two values. You have D and 6, and we know that D is equivalent to 13 on the table. And 13, so you have 8, 4, 2, 1. We're going to make it into a nibble so that we can split these values. 13 is going to be 1, 1, since 8 plus 4 is equivalent to 12, 0, 1, and 6 is going to be 0, 1, 1, 0. The answer is going to be 1, 1, 0, 1, 0, 1, 1, 0. So now these are the 8-bit binary values that are going to be stored in the register for your hexadecimal digits. All you have to do is just split these hexadecimal digits into let's say into nibbles, that is comprising of about 4 bits. So that's the method of conversion from hexadecimal to 8-bit binary values. And yeah, let's move on to the next question. Now the next question talks about HTML color codes. Now HTML color codes and media access control MAC addresses are two examples of where hexadecimal is used in computer science. Now you have to give two other examples of where hexadecimal can be used in computer science. So the first example that I've given here is IP addresses. That's where hexadecimal is used. And the second example here is error messages. You guys can also mention that let's say that hexadecimal can be used in assembly languages or in low-level languages. You can also mention that they're used in URLs or web addresses. You can also mention that they're used in memory dumps or in locations in the memory itself. So you guys can mention that points as well, just for 2 marks individually, so that you guys can score those good marks. All right, let's move on to the next question. Now, the next question is that websites can be created using HTML structure and presentation. Now, you have to state what is meant by HTML structure and presentation. Now, give an example of each in your answer. So, the structure of HTML presentation is mostly the layout of a web page. Now, the example is where text is placed. And the presentation is more of the formatting of web pages. Now this can be example, let's say the font style or the color of the font itself. So you can mention these points for about 4 marks. Alright, let's move on to the next question. Now you have to explain why presentation is often separated from structure when creating a web page. Now, formatting of a page can be changed without needing to alter the structure. So that's the answer that we're going to write just for 1 mark. And that the formatting document can be used again for a different website itself. That's the reason why presentation is often separated from the structure when we're creating a web page. Alright. You can also mention that if further content and web pages are added to the website, you can say that the necessary formatting, it can be easily applied, so that this can save time when developing a website. Or you can mention that the use of CSS, right, cascading style sheets, can be used in formatting, standardized formatting. So CSS can only be needed to be created once to be applied on each website or let's say web page. So you can mention that as well. Let's move on to the next question. Now the next question is that Joel is a student who uses the internet. The table contains 5 terms or definitions that relate to the internet. Complete the table by writing each missing term or definition. So now here we can see that there's a browser. So browser is a software that allows users to view web pages. That's going to be an answer for about, let's say how many marks this is in total is about 5 marks. That's going to be 1 mark in total. Now, this is a company that provides a user with a connection to the internet. That's going to be your internet service provider. This is a protocol that is used to send data for web pages across the internet. That is HTTP. Now, you can also mention HTTPS. That is also known as Hypertext Transfer Protocol Secure. But this definition, this word here just means Hypertext Transfer Protocol. That's it. You can mention either two. Doesn't matter in this case. Now, Uniform Resource Locator, you guys must have seen this every time when you guys use websites. It's also a URL. It's a text-based version of a web address. That's all you need to write down. Now, a cookie, on the other hand, is something like, let's say, a text file. So we have to fill this. You cannot write a cookie just as a text file. You have to mention what a cookie does. So a cookie is like a text file that contains data about a user's browsing habits. So that's what a cookie really means. So it's cookie is just you cannot mention that a cookie is just a text file. That is not allowed. You have to state that a cookie is like a text file that contains data about a user's browsing habits. Now that's a good definition there that you guys can write down for a cookie itself. You can also mention that it stores the user's, let's say, details or preferences in that specific website. Some cookies are good, some are a little off, so it just depends on the website you guys are using. So let's move on to the next question. Now the next question is that Joel uses a firewall to keep her data safe when she uses the internet tick to show which statement about firewalls is true. Now firewalls cannot be hardware or software based individually. They have to be both. They can be both together. So that's why I've ticked the option that firewalls can be both hardware based or software based. Now Joel's parent also uses the firewall to limit the websites that Joel can use. Explain how the firewall is used to limit the websites that Joel can access. So the parents can set criteria for the website that she's allowed to visit. So in this case, we have to mention this for 4 marks. So we can say that the parent can set criteria for websites she's allowed to visit, such as, like, let's say, a blacklist of websites that she can be blocked with. Firewalls they help to examine the incoming traffic and the outgoing traffic, so you can mention that point as well. This is also an important point to write down. You can also say that data is sent from the website that is not allowed should be blocked. So you can mention some points such as that for this 4 marker. Alright, let's move on to the next question. Now, Jason's a programmer who writes computer programs in a high-level language. Now, describe what is meant by high-level language. Now, one example of a high-level language that I can give is, let's say, a Python program. That is a high-level language in this case. So, high-level languages are more like English-like statements. So, do write that point for 1 mark. You can say that high-level languages also need to be converted into machine code using a translator. Now, this is also really important when dealing with high-level languages. You guys can also mention that high-level languages are portable languages, and you can say that one line of code can perform multiple commands. That's also allowed in this definition of high-level languages. Now, Jason wants to distribute a computer program that he has written. He's considering distributing it to users as freeware or free software. Now, explain one drawback to a user if the program is distributed as a freeware. Now, the 2 points that we have to write down is that the user is not allowed to access any source code, so they cannot fix any bugs on it. That's a point that you guys must mention when writing this question down, or the answer down, sorry. Now, the software is still covered by copyright, so you can mention that as well. Explain one benefit to a user if the program is distributed as free software. Now, if it's distributed as a free software, the user can access the source code, so that means they can fix any bugs on it. And you can say that the user can redistribute the software again, just for 2 marks. You guys can mention these points down. Alright, let's move on to the next question. Now, the next question is more related to logic gates, so this is where I'm going to start drawing the diagram here. Okay, so consider the following logic gates. So all I've done here is I converted this statement into a simple equation. That's all. You have to draw a logic circuit to represent the given logic statement. Do not attempt to simplify the logic statement. All logic gates must have a maximum of about 2 inputs. So what they mean by is that it should have 2 inputs like this, not 1 input. This is not how it's going to work. This is the correct version of drawing 2 inputs. Right? So let's just read this statement. About logic gates, one tip is that you have to carefully read what the question is asking you. So you can see that there is an x is equivalent. X is the final value here. You can see that x, is that x is equivalent to a or b. So a or b, or has a symbol like this. So we're going to use a symbol like that for a or b. So we're going to have 2 inputs placed there. So we're going to draw a straight line from here. I'm just going to write this down so that you guys can see that when drawing this diagram. So that's much more clearer for you guys just to see how this thing works. X or C and C. Alright. A or B. So we're going to go one by one. We have to draw A or B. So we're going to have 2 inputs here. So do connect all 2 inputs, like I said. And A or B will have a symbol something like this. This is going to be your A or B. And it's going to be B XOR C. So B XOR C means that it's going to go through an XOR gate. We know how an XOR gate is. It's usually an inverted form of an OR gate, but with changing values. So So you're gonna have two values that are gonna straight here. This is gonna be your XOR gate, but it's gonna be something like this. Now the reason why I've left this loop here for C to be connected like this is for a reason, just to connect to the XOR gate. Now since we know that it's going to be a not XOR gate, so we're going to invert all the values again here. So you're going to draw a not gate, something like this. Once you do that, now what you're going to do is you're going to connect both of them with an AND gate. So you can see that they both connect with an AND gate here. So it's going to be drawn like a symbol like this. And this value is all going to be connected with an AND C. So we're going to connect this value here. It's a bit tight in the diagram, so hopefully you guys can get the idea. What I'm going to draw is a shorthand version of the AND gates. Somewhere around here, I'm just going to draw a diagram of the AND gate being connected with C. So we're going to connect all the loops like that. So where we can see is the pattern is that you guys can see that we're connecting A and B with an XOR gate, and then we're connecting with a not B XOR C. So we can see that happening there, and we connect both of them with an AND gate here. That's going to be placed here. This is going to be an AND gate. Just leave this portion here. Then we connect the whole equation, well, let's say the whole diagram, with an AND gate. By the way, this is an AND gate. It's just drawn like this, right? Similar to a D, but you're just gonna leave it as it is. Now we have to complete the truth table for the given logic statement. So since you know that we have to get the X value, what we're going to do is we're going to start with A and B. So what I'm going to do is I'm just going to write down this XOR statement so we can see that its X is equivalent to, let's say, we have to really write the statement down, otherwise it's not going to work when solving this type of question. It's going to be an AND not, let's just get the brackets correctly, B XOR C, B XOR C. We're going to close the brackets so you can get a value of AND C. So do write down your statement here so that you guys can clearly see how to work out the truth table for this type of logic statement. So the working space is given to you. What you're going to do is you're going to create more columns for the working space itself. So first of all, you're going to have A or B. So what we're going to do is going to add the values of A and B together so that you get the values of about 0, 0, 1, 1, 1, 1, 1, 1. Now, since that is done, now we're going to have a B XOR C. So B XOR C is, I think it is meaning you have B and not C, and you have a positive sign of B of C and not B. So if you are going to open up, we're going to open up the equation like this. So it's going to be B and not C plus C and not B. So what I mean by this is going to have B plus a not C symbol there. So it's going to be not C. So we have to know what B is. So that means these values are going to be converted to 1, 0, 1, 0, 1, 0, 1, 0. You're just going to add these values here. You're going to add them with B. That's going to give you a value of about 1, 0, 1, 1, 1, 0, 1, 1. That's going to be answer for that case. Just going to erase all this. That's the same case with C and actually, sorry guys, we have to multiply. We have to not add because it's an AND gate. So that means you have to multiply the values together. So since this is going to repeat this again, 1, 0, 1, 0, 1, 0, 1, 0. So you have to carefully analyze the table and the equation. This is something about truth tables that you guys have to understand. I'm just going to write down C and not B. I'm just going to create a table there. So it's going to be B and not C. So that means we're going to multiply all of them. So it's going to be 0, 0, 1, 0, 0, 0, 1, 0. Now you're going to convert the same thing. You're going to convert the same thing for a C and B. So this is going to be an inverted 1, 1, 0, 0, 1, 1, 0, 0. You're You're going to multiply all the values of C with B. So you're going to get 0, 1, 0, 0, 0, 1, 0, and 0. Now what we're going to do is you're going to get B XOR C. So B XOR C, that's just going to be an OR gate. You're just going to add these values. You're going to get 0, 1, 1, 0, 0, 1, 1, and 0. Now that was a lot. Now we know the equation states that it has to be a not B XOR Z, so that means everything is going to be opposite of B XOR C, which is going to be a not. So you're going to inverse all the values. So it's going to be 1, 0, 0, 1, 1, 0, 0, 1. Now once you do that, you're going to have an AND gate of this value multiplied all the values in not B XOR Z multiplied by all the values in A plus B. So we're just gonna call this Z. So once you multiply all of them, you're gonna get a value of about, let's say, Z is gonna be, I'm gonna mention here that Z is A plus B, and B XOR C not. So you're going to multiply all the values. You're going to get 0, 0, 0, 1, 1, 0, 0, 1. Alright, once you get that value, you're going to add Z. You're going to add Z with the values of, since it's an AND gate, you're going to multiply all the values of Z with C. So what you're going to do is you're going to delete all these values. So truth tables need to be understood carefully. These are the values of C. These are the values of Z. You're going to multiply them, so you're going to get 0, 0, 0, 1, 0, 0, 0, and 1. This is going to be your answer for about, let's say, 4 marks. So now all we have to do is just write it down here. So you're going to have 0, 0, 0, 1, 0, 0, 0, 1. I'm just going to confirm it with the answer. Final answer is going to be 0, 0, 0, 1, 0, 0, 0, 1. That is going to be your answer for about 4 marks when you guys have mentioned it. So the tip here is just to carefully analyze the table. Just carefully analyze the table. Look at the values carefully. And carefully multiply and add the zeros together. Alright, let's move on to the next question. Now, I'm just going to reload the system again. So the next question is, millions of emails are sent between users on a daily basis. Now you have to identify 2 online security attacks that can be carried out using email. You have to describe how email is used to enable this attack. So the first online security attack that you guys can talk about is phishing. Now the description is that the email is usually sent to the user to ask the person to click on the link given in and redirects the user to a fake website. Now that's going to be your answer for about 2 marks that you guys can mention. And your online security attack 2 can be, let's say, farming. Now farming is similar to phishing, but it works in a different way. Farming is usually, again, an email that's sent to a user, is just encouraging a person to click on the link, and instead it downloads malicious code that will redirect the user again to a fake website. Similar to phishing, but in a different form. It just triggers or downloads malicious code. You guys can also mention virus or malware, is that it is an email that is sent to user to encourage them to click, or let's say on a link or download attachments that could trigger down the downloading of a virus or malware. You guys can mention also DOS attacks, such as denial of service attacks, like a very large number of emails that are sent to a server or network at the same time, which can indirectly crash the server or network. So you guys can mention that points as well for these type of online security attacks. Alright, let's move on to the next question. Now the next question is more about online security attacks that can maliciously damage data. One security method to keep data safe from online attacks is a firewall. You're going to identify 2 other security methods that can keep data safe from online attacks. The first security method you guys can mention is that I mentioned here is encryption. The second security method you guys can mention here is password. You guys can also mention 2-factor authentication / verification. You guys can also mention biometric devices. You guys can also mention, let's say, anti-malware or proxy server or antivirus in this case as well. Now, data can also be damaged accidentally. So that's going to be a point there we have to write down. Give one example of how data can be damaged accidentally is by, let's say, shutting down your computer before saving the data. Or to prevent this from happening, a user should make sure that they have saved all the data before shutting down a computer. Now you have to complete the table by giving 3 other values of data that can be damaged accidentally, and give a method of prevention for each example. So I'm just going to write down all the examples that we can say, like how data is damaged accidentally, and we're going to give prevention methods in order for them not to happen like that. So the first, let's say in the first example, let's say it could be a water, the most basic, like water spilling on the device. So you can say water spilling on a device. You guys can correct the spelling if you guys want. And guys can also mention the prevention method is just don't keep water near it. Don't have water near the device. That's a point that you guys can mention here. Now your second example can be the fire. Fire can destroy the device, right? So fire can destroy device. So you can mention that you're going to say, let's say, use electronics or use electrics safely. Guys can also mention that keep a device in a fireproof box when not in use. Then you can mention that data can be accidentally deleted. Data is accidentally deleted. You guys can also mention that. And you can say that you can add verification method. Add verification as verification method. I'm just going to reload the system again so that you can write down faster. So add verification method for data deletion. Method for data, let's say for data deletion. You guys can also mention to set access levels for data to limit who can delete the data. You guys can also mention that incorrect use of storage device by making sure that the device is ejected before, let's say, removing it. You guys can also mention the physical damage to hardware failure. You can correct care and maintenance of hardware. You guys can also mention that software failure. You can make sure that it's always up to date. Or let's say have the updates regularly updated. Enable automatic updates. All right, that's going to be your answers for about 6 marks so that you guys can understand how to use this. Each point is worth 1 mark. So this is 2 marks, 2 total 6 marks in total. Okay, 1 mark for each point. Alright, let's move on to the next question. Now, Kathy stores data for her business every day. She stores the data using optical data storage. I identified 3 examples of optical data storage. So now this can be CD, DVD, and Blu-ray. And that's going to be your answer for about, let's say, 3 marks. Alright? Okay, now let's move on to the next question. Now, this is 6 statements that are given about the operation of 3 different types of storage. You have to tick to show which statements apply to each type of storage. Some statements may apply to more than one type of storage. So you guys can see that there are 3 types of storage: magnetic, optical, and solid state, and we can see the statements. Now, this storage has no moving parts. That's definitely going to be solid state. This storage uses a laser to read and write data. Now, this can be optical storage. This storage uses a read and write head. That is technically magnetic and optical as well. And this storage burns pits onto a reflective surface. That is optical. This storage uses NAND and NOR technology. That is solid state. This storage stores data in tracks and sectors. That is magnetic, but it could be optical as well, so we can mention optical as well in this case. All right. So these are your points. I'm just checking if they are correct. And yeah, they're correct. All right. Let's move on to the next question. Now, the next question is that Sam develops a software application. He distributes a version of the software as shareware. Describe what is meant by shareware. So you can mention some points here for about 4 marks. Is that shareware is a trial version of software. It's a trial version of software. Guys can also mention it is used with limited features. All right. And you can mention that it is free of charge. That's another point that you guys can add on. You guys can also mention that it's protected by copyrights. You guys can also mention it is a type of software license. That's also allowed in this case. Type of software license. You guys can also mention that it has a number of uses as well. It's a trial version of software with a number of uses, or for a limited time, the limited features, free of charge. You guys can also mention if the full version is required, you need to pay a fee or sign up, or when the trial is over, the user is asked to pay or sign up. All right, let's move on to the last question. Now, the last question states that you have to identify 3 ethical issues that may need to be considered when developing and distributing software. So the first ethical issue is a copyright. That is your first answer. Ethical issue number 2 is going to be privacy of data. That's going to be your next point. Ethical issue 3 is going to be security of software. Okay, security of software. You guys can also mention other points such as plagiarism or production, distribution of malware, intellectual property theft, privacy of data, or let's say age appropriation, offensive materials, environmental impact of distribution, media, example CDs, accessibility of software, or let's say following guidance of professional bodies such as ACM, IEEE, BCS. So you guys can mention all these points for about 3 marks. So it's alright. The points I've mentioned is all about copyright, privacy of data, and security of software. Now this seems to be the end of all the questions. So hopefully you all enjoyed this video, this past paper walkthrough. So if you guys have enjoyed it, please do like, share, and subscribe to the channel. It really helps a lot. And do check out my other videos as well for past paper walkthroughs and topic questions. And do comment below on what your thoughts are about this video, and whether I should continue solving past paper questions or topic by wise questions. And yeah, new content will be posted soon. I think that's it, guys. All right, bye, guys.